Last class we have discussed regarding force voltage analogy and force current analogy. Today we shall discuss regarding the torque voltage and torque current analogy. So here first you observe with the displacement. In a translational system, x is considered as a displacement. That is, x is considered as displacement, but when it comes to the rotational system, theta is considered as a displacement, but both are displacement only. It based on the system. So here if you observe that how many displacements are there, theta 1, theta 2 and theta m. Okay, so first you mark with the three displacement, that is theta 1, theta 2, theta m in the middle, theta 2, because if you observe the circuit here, what it is, first you mark with the theta 1, next you mark with the theta m, next you mark with the theta 2. Okay, so here, so for theta 1 what all it is connected, or you can write first theta 2, next theta m, next theta 1 according to the circuit only. Okay, so in order to reduce the confusion. Okay, so here if you observe the circuit theta 2, so for theta 2 J2 is connected, F2 is connected, it is directly connected. You observe with the reference. Okay, so here, so I have written F2 and J2. So if you observe here in the circuit between theta 2 and theta m, K2 is connected. So write down K2 here, and similarly K1 is also between what? Between theta m and theta 1 in the circuit. So write down it is K1. So for theta m what all connected? Jm is connected, T of t is connected. So write down that is Jm and T of t. Okay, that is T of t. So next here for only theta 1, what are the elements connected? J1 and F1. So write it as J1 and F1. So here three displacements are there. So how many equations you will get? So you will get three equations you will get. Okay, this is a reference you can draw. So three equations. So first equation which is respected towards what? Theta 2. Okay, remember that first equation what we are writing with respect to theta 2. So if you observe here, what you will get? F2. So here F2 is, F1 and F2 is nothing but a friction. Okay, either you can mention like this symbol, or you can mention a box if you are confused. Okay, so better for the friction, always you mention like this symbol and write it a F2. For F2 what we write? F into dx, d theta divided by dt. Okay, like this. Similarly, we don't have torque for the theta 2, so 0 is equal to what you should write? F2 d theta 2 divided by dt plus J2 is inertia. How we write for the mass? Like that only we should write d square theta 2 divided by dt square plus what is connected? K2 is connected. So K2 is in between theta 2 and theta m. So theta 2 minus theta m, because we are writing with respect to equation theta 2. Okay, so the second equation what you should write? We shall write with the theta m. Okay, so that is T of t, that is we start with a torque. Okay, so in the mechanical, that is translational system, we start with a force is equal to like that. Okay, so but when it comes to the here in the rotational system, torque is equal to we start, and instead of mass it is replaced with a here J, that is inertia. So now what you will get for the theta m? Jm is connected, T of t is connected. We have already written T of t, and write down Jm d square theta m divided by dt square plus, and what is connected? K1 is connected, K2 is connected. So write down K1 theta m minus theta 1 plus K2 theta m minus theta 2. So this completes the second equation. Next equation we should write with respect to theta 1. So whether we have the torque, no torque is there. So write it as a 0 is equal to the friction is there. So what we can write? F1 d theta 1 divided by dt plus, so what you should write next? You should write J1 d square theta 1 divided by dt square plus, what it is connected? K1 is connected. So write down K1 theta 1 minus theta m, because we are writing with respect to the first equation. torque voltage analogy, J is replaced by inductance. So friction is replaced by resistance. K is replaced by 1 by C, that is capacitance. So theta is replaced by integration of I into dt, and d theta divided by. So only you remember this much. And one more thing, if you remember this is also enough, because displacement is replaced by integration of I into dt, because here already we are taking voltage, what left here? Current. So you can remember like this, theta is replaced by what? It is current. And here if you differentiate this equation, so what you'll get? D theta divided by dt equal to I. So if you differentiate this equation, what you'll get? D square theta divided by dt square, that is equal to di by dt. It is nothing but similar to force voltage only. So only the mass is replaced by inductance, and here the friction we have changed as a F. No changes. And here the displacement, instead of x we are writing theta. So that is the changes. And torque is replaced by what? It is voltage. The same equation what you write for the force voltage, that only you can remember, but only the thing is displacement is changed, mass is replaced by J. And similarly this also you can remember the force current analogy, so that you can remember this. J is replaced by capacitance. So here J is replaced by inductance, then what left? Capacitance. So here if it is L, here you will get C. And one more thing, K is replaced by what? 1 by L. B is replaced by 1 by R. So when it comes to the current, both are 1 by L, 1 by R. Okay. So here theta is replaced by what? It is integration of V into dt, and dtt divided by dt is replaced by V. D square theta divided by dt square is replaced by dV by dt. So just after knowing the things, you need to replace. So one by one equation we shall write. Okay. So help me with the equation. So first equation we are writing 0 is equal to, what is F2 is replaced by what? Resistance. So R2. If it is F2, it is R2. dtt divided by dt. So what is replaced? I. So that is I2. Plus J2 is replaced by what? L2. D square theta divided by dt square replaced by di by di2 by dt, because it is theta 2. So next K2 is replaced by what? It is 1 by capacitance, 1 by C2 integration of I2 minus Im into dt, because what is there? Theta 2 minus theta m is there. So that's why 1 divided by C2 integration of I2 minus Im into dt. So when you write the second equation, T of T, we are writing with respect to torque voltage. So torque is replaced by what? Voltage. So V is equal to, J is replaced by what? Inductance. So that is Lm. So d square theta means it is nothing but d Im divided by dt, plus again K1 is replaced by what? It is in capacitance, that is 1 divided by C1 integration of theta m, that is Im minus I2 divided into dt. Okay. This is C2, C1 divided by C2, Im minus I2. Next we shall write the K1. Okay. So for K1, 1 divided by C1 integration of, here only it is there. So I have written this one as a first. You don't confuse. So K1 I am writing now 1 divided by C1 integration of. So what it is? Theta m. So Im minus I1 into dt. So this is a second equation. So the third equation, 0 is equal to, F1 means friction. So for friction what we write? Resistance. So R1 it is. R1 d theta divided by dt means it is nothing but I1 plus, what is J1? J1 is replaced by as L1 and d I1 divided by dt, plus K1 is replaced by what? It is here I1 is there, so write down directly 1 divided by C1 integration of I1 minus Im into dt, that is same. Okay. So this is a 3 equation we have converted to torque to voltage, that is loop analysis. If you observe, Im minus I2 is also there, Im minus I1 is also there. So how we should first loop, second loop and the third loop. Okay. So here the capacitance should be for the third loop and the first loop, and first loop, second loop. Between first and second, nothing common things are there. Between, this is a Im, this is I1, this is I2. Okay. So now between Im and I1 what it is there? C1 is there. So we shall write this as a C1. Okay. And between here I1, I2, I am written. So the first equation V equation we shall consider because it is a voltage is there. So first voltage, so it is related to IM equation. Okay, we have written this equation with respect to motor. So first we shall write voltage here, voltage it is, and here LM, that is only it is related for this case, this is LM, and here what it is there, 1 divided by C2 IM minus I2. So here capacitance, that is C2, and one more capacitance is C1, which is here, that is C1. So it is completed. Now the second equation R1 I1. So it is related to what? It is related to the first equation. If you observe here, it is related to what? It is related to I1 equation. Okay. So R1 I1. So where you should draw R1 I1. So here you can put the resistance. It is R1 I1. Next L di1 divided by dt. So here only you put a inductance and resistance. This is L1. Okay, so here it is L1 and here it is R1. Roughly I am drawing. Okay, so L1 R1, and next to what it is, C1 is mentioned already. We have mentioned C1 is between IM and I1. Okay, the second equation also completed. Third equation. So for now we shall go to the first equation, that is R2 I2. So R2 I2 means here the resistance should come R2. Okay, because it is only related to the I2. Okay, so next to L2 is only related to the I2. So we shall draw like this. It is L2. Okay, so next C2 we have already drawn. It is in between IM and I2. So this is what we get a torque voltage analogy. Next we should write the equations for the torque current analogy similarly. We write F2 is replaced by 1 by R2. So d theta 2 divided by dt is replaced by, that is V2, plus J2 is replaced by capacitance C2, and d square theta, that is nothing but dV by dt, plus, so it is K2 is nothing but 1 by L2, that is theta 2 means integration of V2 minus Vm into dt. So this is the equation, first equation. Second equation, T of t, we are changing torque to current. So I of t is equal to, so what is a Jm is nothing but what it is, Jm is nothing but C suffix m. Okay, so next d square theta m divided by dt square means what it is, dv by dt. So d, it is related to the second equation, so write down V2. So it is related to theta m, so it is K1, K2 is there. So K1 is replaced by what? It is inductance 1 by L1 integration of Vm minus, it is V1 into dt, plus 1 by L2 integration of Vm minus V2 into dt. So this was there in the question, that is K2 and K1 is replaced by inductance, theta m is replaced by Vm, theta 1 is replaced by V1. Okay, similarly this also we have replaced by. Now the third equation we shall see, 0 is equal to F1 is replaced by what? It is F1 is replaced by 1 by R1. So d theta 1 divided by dt is replaced by, it is nothing but V1, plus, so you remember I is equal to what we write, V by R, right? So like that you remember. So J1 means what it is, J1 is replaced by C1. So d square theta 1 divided by dt square, what we write, d V1 divided by dt, plus again K1 is replaced by what it is, 1 by L1 integration of V1 minus Vm ddt. So how we draw the circuit, it is similar to the equivalent circuit if you observe. So instead of K2 and K1 we have written just the if you observe here, instead of, always current means the same equivalent circuit what you draw, the similar it will be. So here instead of theta we have replaced with a voltage, and K is replaced by inductance. In the bracket you should write 1 by K2, and similarly for the friction it is resistance. I have drawn resistance symbol. So for the J2 it is a capacitance, I have written as a capacitance. For Jm, Cm, and for the T of t, that is torque is replaced by what it is, torque is replaced by current, that is I of t, and J1 is replaced by capacitance C1, F1 is replaced by R1. In the bracket you should mention 1 divided by B1. Here also you should mention 1 divided by B2.